if you've just forgotten, hopefully we can pick that up. Today's going to be what a logarithm is, how to evaluate it. Tomorrow we'll look at properties of logarithms. And then next Monday we'll look at solving logarithmic equations and exponential equations. So we're going to spend 3 days on logarithm things. The first thing I wanted to do is go back and introduce you to what a logarithm is. If you understand what it is, it takes the fear out of it. I think that's the biggest thing with logarithms is the fear that we see. It's a little scary. So I had you graph 2 to the x. You can plot points and use properties of exponents to do that. Okay? Find the domain and range. What's the domain of 2 to the x? What's the range?
No, it's parentheses.
Why?
Because it doesn't touch it.
It doesn't touch 0. It gets really close, but it doesn't touch it. Graph the inverse. What do you know about inverses?
F of x negative 1 is flipped over the it'd be 1 over 2x.
What does a line y equals x? X and y are switched, right? An inverse in definition is that the domain and range, the input and output, are switched. Remember trig functions, it was the same way. The angle became, we would do the ratio inside, and that gave you the angle instead of the angle in, and it gave you the ratio. So the input and output are switched. So the graph of the inverse, if you didn't know what the inverse was, the graph of the inverse is, instead of 0, 1, I would have 1, 0. Instead of negative 1, 1/2, I would have 1/2, negative 1. Instead of 1, 2, I would have 2, 1.
Yeah.
And if I wanted to plot more, I could, instead of 2, 4, I'd have 4, 2. And yes, you do get a reflection of the line y equals x. I heard several of you say that you would do that. So the red line is the inverse. What's the domain and range of the inverse? It better be the exact domain and range of the original except reverse, because that's switched to x and y, right? So which leads us to something you notice in your algebra before calculus. You notice today we're talking about the inverse of an exponential, which is a logarithm. You notice that the domain of a logarithm was 0 to infinity. That you couldn't plug negatives into a logarithm, you couldn't plug 0 into a logarithm, right? So notice that? So, now you know why. That's because it's the inverse. Okay, so if I wanted to find the inverse of y equals 2 to the x, I would have x equals 2 to the y, right? 2 x and y, that's how we find inverses. And I would solve for y. Mathematicians hit a dilemma here. They were like, I need an inverse to solve for y. I'm trying to find an inverse. Catch 22, right? So mathematicians, the brilliant people that they are, they just defined an inverse. So they said that y is the power 2 is raised to get x. How many times do you think they wanted to write that down? 0 times. Right? So they needed a name for that. Right? That's what they did. They said y is the power that 2 is raised to get x. And they gave that a name, and they called it a logarithm. Why they called it a logarithm, I don't know. I don't speak Latin. But somewhere back then, they called that a logarithm. So log raised to x just simply means the power that 2 is raised to get x. Y is the power that 2 is raised to get x. So x equals 2 to the y is not scary at all. Y equals log base 2 of x is scary, right? It's got lots of letters and math that freaks people out. So, what are we going to do every time we log? We're going to think exponentially. So the whole goal of today is to think in exponentials. Was yesterday difficult? No, exponentials are not hard. So, in turn, logarithms are not hard either. And unless you make they're just exponentials. So we're going to keep that in mind. Before we do some logarithms, let's talk about the graph. I'm not going to regraph it, but it's the graph you have on your paper from the bell ringer. That is log base 2 of x and 2 negative x. That is the two graphs you have there. Log base 2 of x is the inverse of 2 of x. Are there any asymptotes on a logarithm? Yes, what kind of asymptote? Vertical asymptote, right? The y-axis or x equals 0 is a vertical asymptote on a logarithm. Remember, an exponential had a horizontal asymptote, y equals 0, so x equals y. A vertical asymptote. The x-intercept, 1, 0, always on a logarithmic graph. Any logarithm, because any exponential has a point 0, 1, so won't any logarithm have a point 1, 0? As long as it's not shifted. Good. Domain of a logarithm that's not shifted is 0 to infinity. Range of a logarithm, shifted or not, is negative infinity to infinity. So you remember that question on AP or on the behind the calculus question that asks you the domain and the range of the logarithm? It's the thought process you would go through. Other points on a logarithm, the base 1 is always going to be a point. Why is the base 1 always going to be a point on a logarithm? Good. Anything to the first power is the number, so we switch x and y, we would get the base 1. And then 1 over the base, negative 1, is always on the graph. Makes sense. Some interesting information about logarithmic graphs. I can go back. Is it coming back? What a logarithm is? Second time rounds off. Exponential. So, if I want to graph log base 4 of x, log base 4 of x scares me, right? But what doesn't scare me? 4 to the x, right? 4 to the x is fine, I can handle 4 to the x. So I'm going to think of the 3 points that would be easy to plot.
Wait, can you write the equation that we're thinking of? No, they're laughing at me.
Okay. So negative 1, 0, and 1.
That's still not an equation. It's a use.
Y equals 4 to the power of x.
Thank you. That's what I wanted. Michael?
Just think.
Yourself. I had this on recording.
So if I plug negative 1 in, I get a 4. 1 over the base. Everyone agree? If I plug 0 in, I get
1.
and if I plug 1 in, I get
4. Oh. Yes.
So what's the set of points on the logarithmic graph?
Split the y.
All the x's and y's are switched. So you remember me writing this down?
Yes.
You always have the x-intercept at point 1, 0, and then those 2 points are always on the logarithm. Well, that's why, because it's those points switched around. So 1/4 negative 1, 0, 1. So what would that be? 1, 0, and 4, 1. And so 4 to the x looks like that. She just made tables are make a table. I like tables.
I like tables too.
She counted off on homework.
The lowest test grade I got all year was like 90 because I refused to put tables. Or I just forgot. Just didn't.
You refused.
Any questions so far? Okay, so anytime we see a logarithm, we're going to think in exponential format.
unit circle?
No.
Yes, we learned that last year.
No. So this is totally non-mathematical. You can hate it if you wish to never do it. But anytime you see a logarithm, you can rewrite it as an exponential by drawing a circle. B to the x equals y. B to the x equals y. Draw a little circle, b to the x equals y. That's how you convert a logarithm back to exponential format. You will want to do that because remember, logarithms scare us, exponentials don't. So I'm going to want to convert those back to exponential format. Now you can also just think about it, the base always stays the base. The logarithm is the exponent, because that's how it's defined. Log base b of y is the power you raise b to get y. So you could just think about it and get there, but the little circle thing just makes it quick. So b to the x equals y. You need to memorize that conversion. I would tell you to put it on a note card, but you already have it on a note card. So look at your note card. You might not have the circle thing, but you have the conversion. Any questions?
So the last one would be 4 to the y.
Okay, so write these in exponential format. Log base 2 of 128 sounds scary. 2 to the 7th equals 128 is not terrifying at all. Okay? Sure. Yeah. It just says write it in exponential format.
That'd be 4 to 0 equals 1.
Does that make sense? Makes perfect sense, right?
Yeah,
Question. What's log base 3 of 1? Gonna equal. Why 0? Anything to the 0 power is 1. So log base anything of 1 would have to be 0. Makes sense. That's not what we're doing on this slide, but. So what's the rewrite?
4 to the power of 0.
Y'all like the circle thing?
Yes.
Okay, don't use it. You don't like it.
Try it for a bit. And this way you don't have a cool circle thing, so we will have to think about a cool circle this way. But what I would do is on the side of my paper write that. I do the little circle thing and keep this sitting on the side of my paper so that I can find out what piece goes where. Base always stays the base. So what's the base here? So it's log base 10. Equals 3.
Good. The answer to a logarithm is an exponent because a logarithm is an exponent.
To 1,000.
And then if you really like the circle thing, you can check the both 3 numbers. You don't get it right first time. Any questions there? You may remember, and I have it on a slide later, you may remember that could also be written as log of 1,000 equals 3. Because if you write logarithm without a base, it means base 10. So, now we'll talk about this. What's this one?
1/2 y equals negative 2.
Any questions about that? There are 2 special logarithms, log base 10 of x and natural log of x. They are special because they are so commonly used. That's why log base is called common log. I want to talk a little bit about why they're so commonly used. How do we count? My 3-year-old. Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we start over. 1, 1, 11. Right? So our number system is base 10. Not every number system in the world is base 10, but ours is base 10. So when we do things like scientific notation, there are a lot of exponents that use base 10 because commonly used that we have a logarithm specifically for that number because that's our number system. And mathematicians are notoriously lazy. And so if they use something enough, they're going to give it a shortcut name. So like Houston's used enough, they just call it log. The log button on your calculator is that. There is a log base button on your calculator. Does everyone know how to get to it?
Yes.
Alpha window. Alpha window is the log base button. Number 5. That's alpha window. Number 5 is log base. That is a new button on your calculator. It's only been on those calculators for about 4 years, so you are benefiting from that. We used to have to teach what was called the change of base formula. We did it for one of those 2 bases. Okay, natural log. It's common because of biology. Y'all may remember from Algebra 2 the PERT formula.
Whatever you use
Or
to
from biology, maybe.
increase.
So, if you have continuously compounding interest, well, what compounds continuously?
Yeah.
Well, you remember you first learned things with money, right? Well, money compounds normally monthly or daily. It never actually compounds continuously. Books will have you do problems where it compounds continuously. My husband gets really mad at me when I do those examples. Not really. It doesn't make that much difference. Compounding doesn't change it as much as the interest rate changes. It changes slightly, but the interest rate's really the big factor. Compounding is when the bank stops, puts in your interest, and then calculates interest again on your interest. So they put the interest in your account. So some banks do that quarterly, which is 4 times a year. Some banks do that monthly. Does anybody have a savings account? You see when that little interest goes in, it's probably like 5 cents right now or something stupid. But you get a little bit, and that's when your bank is compounding your interest. Banks always compound at some period of time because that's the only thing they have. What compounds continuously? Population. We don't stop once a month and be like, okay, rabbits, dope, babies now. That's not how it works, right? It's just always happening, right? So you can see the population is compounded continuously. More information. Okay, evaluate logarithm. That looks scary, right?
Yeah.
So how do I make it not scary?
Think. Oh my God.
Y'all are goofy. Okay, log base 3 of 9. Wouldn't that be 3 to what power equals 9? And so 3 to what power is 9? 2. That's scary, but that's not. That's scary, but that's not. So it's not scary if you rewrite it. If you rewrite an exponent or a logarithmic function as an exponential, you will simply be asking yourself properties of exponent questions. Log base 2 of 8. What am I going to ask myself?
Sure.
3.
Okay, why 3?
It's
To the third power. Just
Thought of it.
Any questions about that one? Right here.
Number 2?
This here.
Did you call it? No.
He was trying. I don't think he actually got there.
-2?
1/2.
Ooh, why 1/2?
Because it's trying to answer the root.
25 to what power is 5?
1/2.
It's not a fraction, so I don't want a negative, right? But I want to do a root of some sort. In this case, I want a square root, and I learned yesterday or the day about whenever we learned that a square root is a 1/2 power.
Yeah, what would it be? Would it be a cube?
is 0. Now, just for mental note, what is the base there?
10.
10. So 10 to what power equals 1? To the 0 power.
Uh-oh, challenge problems.
So, try these two. Don't say it out loud yet.
I was.
Try.
You really fall asleep.
Oh, yes it is.
Go. Right.
You probably put a skip right. You probably put a skip right.
I thought about it. Oh. Tricky.
I think y'all are enjoying logarithms too much.
No, we don't really enjoy them.
Oh my god. I know it is. Sing. It's good.
Are they easier than you remember? Don't remember them at all.
I was so bored. One of those things.
Next one.
One.
Okay, what would 1/3 make it?
Cube root.
Okay, what's cube root?
27.
So we don't want that, do we?
True.
Do what?
Thank you, Brad.
Okay, 1/2. What would that do? That would good. 1/2 would square root it and make it 3, right?
Yep.
But then I want the 3 to be cubed. So 3/2.
Oh.
2/3. 2/3.
Oh.
Gotcha.
That's hard.
Yes, you will.
No.
3 cubed is
The 9, the square root of 9 is 3. 3 cubed is 27. Is that what you said? So that's the thought process. Is what would I do to the 9? Well, I kind of need to take them down to the same base number, and they both have a 3 in them. So square rooting 9 would get 3, and then 3 cubed. The root is on the bottom, the power is on the top. How do I know that?
Because that's the rule.
That's the rule, and I don't break rules, right?
No.
Don't break.
Intermittent.
No.
You can
You can't just do it.
You can't phrase anything.
What's that mean?
Not possible. True God.
What about if that had been log base 2? So we know any negative number is not going to work, right? What if we try to do log base 2 of 0? Can that work?
No.
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 No, because that's
That is why the domain of a logarithm is 0 to infinity with parentheses.
straight up.
Oh my gosh. Creativity.
No. You're right up to work first. 1 through 24 all and 28. Calculator is only allowed if you can't do it by hand. Well, I know that you would be unsure which ones you could or couldn't do by hand. So I did not leave that up to interpretation. The ones you can't do by hand are those. 9, 11, 14, 16, 17, 18, and 21. So you're allowed to use a calculator on those. The rest, no calculator. Like maybe it's natural log of 3. E to what power equals 3? I have no idea.
This test over the algebra, are we going to have to calculate?
On some of it. Hey, really, really fast. If I wanted to grab log base 3 of x minus 3, I would grab
using those, right?
Yeah, do my help on this. Do that.